Calculus 1 Final Exam Review, Problem 2. We begin these limit calculations by direct substitution. We replace x with 7. 3 times 7 divided by the quantity square root of x plus 2. We get 21 divided by the square root of 9. 21 divided by 3 equals 7. In part B, we are taking the limit as x approaches 3 by direct substitution. 3 replaces x. We have tangent of the quantity 3 pi divided by 4. And this is equal to negative 1. In part C, again, we use direct substitution as our initial approach. We replace x with 1. We get the natural log of 3 plus e. Now in part D, if we use direct substitution, we get 0 divided by 0. This is an indeterminate form. Indeterminate means you can't tell what the limit is or even whether or not it exists. We have to use some other technique. Let's try algebra, specifically factoring. And since in a limit evaluation, as x goes to 0, x is not ever equal to 0, we're not dividing by 0. And we get 1 divided by 1. We have the limit as x approaches 0 of 1 divided by x minus 1. Now we try direct substitution again. 1 divided by 0 minus 1. We get a limit value negative 1. In part E, we will do something very similar to part D. Again, begin with direct substitution. As we will see shortly, we will again get the indeterminate form 0 divided by 0. So let's use some algebra. Factoring again. The numerator factors as x plus 3 times x minus 2. The denominator factors as x plus 3 times x minus 3. In a limit evaluation, as x approaches negative 3, x is never equal to negative 3. That means neither of these factors is 0, so we're not dividing by 0. And those divide out to 1 divided by 1. We have a limit as x approaches negative 3 of x minus 2 divided by x minus 3. Direct substitution produces negative 5 divided by negative 6 for a limit value of 5/6. In part F, direct substitution produces square root of 4 minus 2 divided by 3 minus 3. Once again we get the indeterminate form 0 divided by 0. What kind of algebra can we do here? Factoring won't work. There's a nice little maneuver where we multiply by the conjugate of that more complicated numerator into the numerator and into the denominator. The conjugate would be square root of x plus 1 plus 2. We multiply that into the numerator and denominator. What you see in red here, what I just multiplied in, is equal to 1. So I've just multiplied this expression by 1. Its value is not changed. When you multiply the square root of a quantity with itself, you get the radicand. Here we get x plus 1. Now we multiply this radical with this 2, and we get plus 2 times the square root of x plus 1. Now this negative 2 multiplies with this radical. We get the exact opposite of the preceding term. And completing the FOILing, the multiplication, negative 2 times positive 2 is negative 4. From experience, I am not going to multiply the two factors of the denominator together. I will leave them in a formal multiplied state. It would not be wrong to multiply by FOIL, but it would not be advantageous. Notice that the numerator has two terms that add up to 0, and the rest of the numerator simplifies to x minus 3, which is one of the factors in the denominator. These factors divide to 1. We use direct substitution. We have 1 divided by the quantity 2 plus 2. The limit value is 1/4. In part G, we must evaluate this limit. We will appeal to a special limit from the textbook. This is one worth memorizing. This limit is equal to 1. How do we apply it? This 5 in the denominator is equivalent to multiplication by 1/5. Properties of limits allow us to factor out multiplied constants. We have 1/5 times the limit as x goes to 0 of sine of x divided by x. 1/5 times that so-called special limit value of 1. Our answer is 1/5.